In today's lesson, we'll be investigating properties of triangles. Here are the key concepts for today. I'm going to explain these using some diagrams. If you look at the triangle to the left, I'm going to draw a median. These two sides are equal. A median bisects the area of the triangle, which means the area of this triangle over here will be equal to the area of this triangle over here. If you draw in all the medians, they will meet at a single point, and that point is called the centroid. If you look to the right, we have a triangle, which is an isosceles triangle. I'm going to draw a median from the vertex, which is sandwiched between the two equal sides, if you draw a median in an isosceles triangle in this specific position, it is also called the altitude, as it will make a 90-degree angle with that side of the triangle. This median and altitude will also bisect the angle at the vertex, which means this angle will be identical to that angle. In the second part of today's lesson, we'll be verifying the properties of triangles. Here are the key points for today. I'm going to show you diagrams related to these 2 points. In this diagram, we have 3 medians drawn within a triangle, and they meet at a single point. If you recall, this point is called the centroid. Look at median RP. You'll notice that the centroid divides it into 2 parts. So I have this bottom part over here, and I have this top part over here. It's pretty clear that one part is longer than the other part. In the previous slide, it states that one part is twice the length of the other. I can write this like so. Line segment PC is twice the length of line segment RC. The same holds true for the other medians which have been divided into 2 by the centroid. In this diagram, we have a triangle whose midpoints of D and E have been written in. So I'm going to write a little note that these are the midpoints. If you connect these midpoints, a special relationship will appear between these 2 lines. First off, DE will be parallel to line segment AB. So we can indicate that with a little arrow like that, which means they are parallel. And if you look closely at these 2 lines, one is longer than the other. There is a special relationship between these 2 lines. DE is 1/2 the length of line segment AB. Or alternatively, you can say AB is twice the length of DE. In our first example, we want to determine an equation for the line shown with each triangle. If you recall, the general equation of a line in slope-intercept form is y equals mx plus b. That means we need to figure out the slope of this line as well as the y-intercept. To figure out slope, we need 2 points on the line. We know 1 point on the line, and we know another point on the line, but we don't have the coordinates for point D. But we do have these two coordinates, and since D is the midpoint of line segment CB, we can easily use the midpoint equation to find the coordinates of D. I'm going to write the general strategy for these questions. So the very first step is to find the midpoint D using points C, B, and the midpoint equation. I'm just going to use EQN for equation. As I mentioned earlier, the next step would be to find the slope using these 2 points. So I'm going to write find slope of line using points A, D, and slope equation, which is rise over run, or y2 minus y1 over x2 minus x1. Once we figure out the slope, we still have to find the y-intercept, which is b. As you've learned in previous units, you can substitute the slope value and any point on the line. In this case, that would either be A or D into the equation y equals mx plus b, and then you will solve for b. The very last step would be to take those values. So sub slope and the y-intercept value, which is b, into y equals mx plus b. And that will give you the equation of this line. So again, I'm not going to show you all the work for this question. The general strategy is what is most important. In our second example, we want to verify that DE and BC are parallel. Now the key word is parallel, which means they have the same slope. If we are looking for slope, we need 2 points on each line. I have 2 points down here for line BC. I have 2 points on the line of DE. However, I do not know their coordinates, but I do know that D is the midpoint of AB and E is the midpoint of AC. So let's go ahead and write a strategy for this. So our first step is to find midpoint D with points A, B, and the midpoint equation. The second step would be exactly the same, but with point E. So I'm going to rewrite that. Find midpoint E with points A, C, and the midpoint equation. Our next step would be to find the slope of each of these lines, and you should know how to do that already, but I'm going to write that out. Find slope of DE using points D, E, and the slope equation. Our last step is going to be very similar, and I'm going to write find slope of BC using points B, C, and slope equation. And last but not least, finding these values aren't good enough. You want to compare them. So I'm going to say if the slope of DE is equal to the slope of BC, therefore DE, the line segment DE, will be parallel to the line segment of BC. And that's ultimately what we want to prove. And finally, I'm just going to zoom out to show you all the work that is required for this one example. In our third example, we want to show that the right bisectors of the sides of triangle DEF all intersect at point C, which is called the circumcenter of the triangle. I'm going to draw a right bisector in my diagram. It's going to look something like this. It's going to form a 90-degree angle with that side of the triangle, and this length is going to be equal to that length. I'm going to call this point H. Since the right bisector of EH meets DF at a 90-degree angle, we know that their slopes are negative reciprocals. So if we know the slope of DF, we can easily figure out the slope of EH. So let's write down that as a step. Find slope of line segment DF with points D, F, and the slope equation. The slope of EH will be the negative reciprocal of the slope of DF. Our next step will be to find the coordinates of H. That should be pretty simple. So let me write a step for that. Find midpoint H with points D, F, and the midpoint equation. Because we have the slope of EH and we have the midpoint of H, which is a point on the line, we can use these values to figure out the y-intercept. So let's go ahead and write that as a step. So I'm going to say substitute the slope of EH and any point on the line. In this case, the only point we have is point H. And we're going to substitute that into y equals mx plus b. And once we do that, we can easily solve for b. Now that we've figured out what b is equal to, we have the slope already, and now that we've just figured out b, we can write the equation of this right bisector. So I'm going to say sub the slope of EH and b into y equals mx plus b, and that will give you the equation of that right bisector. We're not quite finished. We want to figure out if C is a point on this line, this right bisector. So to do that, you need to do a left side equals right side check. So I'm going to write those instructions in. Sub C, and that point is -4 and 4, into the equation of the right bisector that you just determined. And you're going to do a right side equals left side check. If it passes this right side equals left side check, that means this point of C is located on the right bisector. We are going to do the exact same steps for the other 3 right bisectors. I'm not going to go through all of those steps, but the process is identical. In this last example, we want to verify that point C is equidistant from all the 3 vertices of this triangle DEF. Equidistant basically means it's the same distance from each vertex, which means this distance is equal to this distance, which is equal to that distance. Because we have the coordinates of each of these points, it should be pretty easy to figure out the distance between these points. So let's write some instructions. Find distance between points D and C points F and C and points E and C. With distance between 2 points equation. Once we figure out these values, we need to compare them. So let's write a step for that. If all 3 distances are equal, therefore point C is equidistant from all the vertexes. And I'm just going to zoom out to show you all the steps that would be required to solve this question.